Assalamualaikum warahmatullahi wabarakatuh. Okay, so I welcome you to our group project presentation. So our group has been assigned for case study number 9, and the company that we will be presenting or will be hosting is Sakura Sendirian Berhad. And without further ado, let's move on. Alright, moving on to the group members. Our group consists of about 5 members. The first one is Naufal Hakimi bin Suhaimi and myself, Muhammad Syami bin Muhammad Ismail Wijah, Naufal Harid bin Zulkifli, Muhammad Hanafi bin Abdul Hamid, and also Ahmad Firdaus bin Ahmad Sarid. Moving on to the introduction, as we all know, in today's digital era, a stable and also a secure network is basically an essential for companies to operate more efficiently and also to stay competitive in the market. So our team has designed and also implement a wireless network for Sakura Sindrian Berhad, which is an animation company. Our goal is to build a reliable WLAN to support 25 laptops and also 5 mobile devices, along with a web server to share the company's information about their services and also events. We have focused on creating a secure and also scalable network plan and also tested it using Cisco Packet Tracer. This report outlines the network physical structure, the server setup, and also the testing process, as well as the chosen topology with its pros and also cons. We also include the cost breakdown covering the devices, the cabling, the hardware, the software, and also the installation. Throughout this project, we have applied theoretical concepts to develop a practical networking solution for real-world scenario. Okay, let's move on to the physical structure. As you can see on the left side, you can see the physical layout of Sakura Sendirian Berhad office. Okay, the network uses a centralized star topology that integrates both wired and also wireless connection. At the core is a router that manages their data flow and also provide internet access connected to 2 switches. One switch links to a wireless access point that connects all staff laptops and smartphone, while the other switch connects to a server that hosts internal resources. Separating user and also server traffic will improve the performance and also in management. All core devices are connected via high-speed Ethernet cables, while staff devices uses Wi-Fi for flexibility. This setup will make sure an efficient communication and also supports future scalability.
Now let's move on to network topology. Its name. This network uses an extended star topology that's combined wired and wireless segment. For wireless section, we have access point that is functioning as a central hub. It connects directly to 35 laptop and 5 smartphone. It handles all the wireless traffic and forward it to the correct destination. As for the wireless section, we have a router, a switch, and a server. The router serves as the main central device for our network. We also have a switch named switch VLAN that's connect access point to the router and a switch server which connected the router to the server. This separate user and server traffic for better performances. This topology ensures centralized communication, organized structure, and scalability.
Okay, so now let's proceed to the next slide, which is advantages. So there are a total of 4 advantages for our case study number 9. And first of all is centralized management and easy troubleshooting. Central control through router and access point. Easy to monitor and manage 25 laptops and 5 mobile devices. Fast fault detection and isolation due to direct connections to the central hub. Second, high reliability and fault tolerance. Failure of one device or cable doesn't affect the rest of the network. Each device has a dedicated connection, ensuring stability, critical for uninterrupted animation work and project delivery. Third, easy network expansion and scalability. New devices can connect wirelessly without disrupting the network. Supports future growth by adding more access points or switches. Flexible for company expansion. And last but not least, high performance for each device. Dedicated wireless connections ensure consistent speed. No shared communication paths equal to better data transfer rates. And last, ideal for large file sharing and web server assets in animation tasks. Moving forward, the next slide highlights the disadvantages for our case study number 9. So there are a total of 4 disadvantages for our case study number 9. And first of all is single point of failure rates. Failure of access point disconnects all 25 laptops and 5 mobile devices. Failure of router disrupts all communication between users and the server. Critical processes may halt or terminated completely if central devices go down. Second, higher implementation and maintenance costs. Total setup cost is high, approximately Rm 40,100. Expensive components like high-end router, switches, and server. Recurring costs for software subscriptions and potential upgrades. Third, limited by central device capacity. Access point and router have limited bandwidth. Performance may drop with more than 30 devices. Large file transfers or simultaneous server requests can cause congestion. Last but not least, complex cable management for wired components. Star topology requires individual cabling from each switch to the router. Extensive Cat6 cabling adds complexity and potential cost increases. Office layout may require additional planning for cable routing and protection.
Alright, so we're moving on to the network and connecting devices. So first we have router. It is the central device that connects our different network segments. Also, it helps manage the flow of data between them. Next, we have switches. These are smart devices that help us organize our network. First, we use one switch to connect all our wireless traffic from the access point and another switches for our server. This helps separate traffic and improve overall performance. And also to provide Wi-Fi, we use access point. It takes our wired network and converts it into a wireless signal, allowing devices like laptop and smartphones to connect without cables. Also, we have a server. So in this project, the main job of the server to host the company internal website. The server use service like HTTP to deliver that content to anyone on the network using a web browser. And lastly, we have the end devices. For our case study 9, we need to provide 25 laptops and 5 smartphones used by the staff. So we're moving on to the transmission media use. Now let's talk about how these devices are actually connected. In any network, data travels we call transmission media. For this project, we use 2 types. First is wireless media, or as we know is Wi-Fi. It uses radio wave to send data through the air. For a modern office with a 30 wireless device, the recommended standard is Wi-Fi 6. It is fast, handles many connections at once without slowing down, and it is perfect for this setup. So next is wired media. Specifically is Ethernet cable. For the core connections like linking the router, switches and server, we use copper straight through Ethernet cable. This cable can support speed up to 10 gigabits per second, ensuring a fast and stable connection for the most critical part of our network. That is for transmission media use. Next, I will show you how to configure the router for our group project. Moving on to the router configuration. So as you can see on the screen, on the left side, we are in the configuration menu for the router. So we will start by setting up the Gigabit Ethernet 000 interface. So first, we need to make sure the port status is on to activate the interface. So for this interface, we have set up the IPv4 address to 192.168 and 11, and the subnet mask to 255, 255, 255 and 0. This IP address will act as the default gateway for the first group of devices in our star topology. Moving on to the right side, so we will configure the second interface on the router Gigabit Ethernet 001 to connect to our other set of devices. So just like before, we ensure the port status is on. So for this interface, we have assigned the IPv4 address as 192.168.21 with the same subnet mask. So this creates a separate network, and this IP address will serve as the default gateway for the devices connected to this interface. So by configuring these two interfaces with different network addresses, Our router can manage traffic between the two separate networks. After configure the router, we need to do a server configuration. We will click on the server, go to the desktop tab and open the IP configuration window. First step, we need to click a static option, and for the IPv4 address, we have assigned as 192.168.2 and 100. So this address is on the same network as the second interface of our router. So the subnet mask is 255.255.255.0, which defines the size of this network. And most importantly, the default gateway we set up as 192.168.2.1. So this is the IP address of the router interface that we configured earlier for this network. So with this configuration, the server is now fully a functional part of our network, ready to provide service to other devices. After configure the server, we need to configure the access point to provide wireless connectivity in our network. So as you can see, we are in the configuration setting for the access point, which is port 1. So first step, we will give our Wi-Fi network a name, or SSID. So we have set it to Sakura wireless LAN. This is the network name that user will see when they try to connect. The second step is we need to secure our wireless network. So we have chosen WPA to PSK for authentication, so which is the standard for strong Wi-Fi security today. And lastly, to connect, a user will need a password. So we have set the PSK passphrase to Sakura 123. So with these settings in place, our access point is now broadcasting a secure wireless network. Okay, so now our access point is ready broadcasting. So we will connect the devices to our access point. So first, we go to the laptop desktop and we click the PC wireless, and as you can see, it automatic scan for available networks and finds our network, which is Sakura wireless LAN. So we select it and click connect. So we enter the password that we already created before, which is Sakura123, and click connect to establish the connection. So once connected, the laptop needs an IP address to communicate on the network. So we will configure this statically. So the IPv4 address we set up to 192.168.123, which is on the first network, and the subnet mask is 255.255.255.0. The default gateway is 192.168.1.1, pointing to our router first interface, and importantly for the DNS server. So we have set up the DNS server to 192.168.2.100, which is the IP address of our server. So this tells the laptop how to find the server when we use a web address. So after configure the server, router, and also the access point, we can test them if they can communicate. So we will use the ping test and we try to web browser.
Now let's take a look at the ping test. The ping test is the basic network diagnostic tool used to verify whether or not one device can reach another over an IP network. In this project, the test was used to check the connectivity between two wireless laptops. First, in order to do the ping test, we need to get the IP address of the laptop. We can use ipconfig command to get the IPv4 addresses in each laptop. For reference, the laptop that we're using both use IP address 192.168.115 and 192.168.123. Then we use the ping command to send a 4 packets of 32 bytes of packet from one laptop to the another. Now, as you can see from the screenshot, we have both laptop A and laptop B successfully received or reply. They also have 0 packet loss, which confirm that their wireless connection via access point is working. IP address and routing are correctly configured, and network communication between wireless devices is stable and functional.
Alright, moving on to our web server. The screenshot shows that the homepage, or what do we usually call a landing page, which is index.html, has successfully loaded in the client's web browser. This page displays a welcome message for Sakura Animation Studios, confirming that the web server is accessible for the employee to connect from a wireless device. Next, we have a services page. This page will appear only if the user click on our services link on the header beside the homepage button. So this page provide details about the 2D and 3D animations, motion graphics and other services offered by the company. So for the last page, which is events page, this page will display a schedule of upcoming activities and events for the user in Sakura Animation Studios. The details about the events or activities here is include such as its date, events type or name, and the location it will be held. Let's move on into our detailed cost of implementation. First up, we have network devices and cabling. So for the first item, which is router, we will be using a model Cisco ISR 4331 K9, price at 4,000, which is for business level security and reliability. Next, we have switch, which is Cisco Catalyst 2960240CL, prices at 2,650. This will provide a stable and fast connection for all of our devices in Sakura Animation Studios. So for the access point, we are going with 1 Ubiquiti Unify 6 Lite, price at 750. We are choosing this model because of the latest Wi-Fi 6 technology that it will provide us. So for the last network devices and cabling, so for the cable, we will be using Cat6 cabling for office, quantity at 1 lot, and the price is 600. Next, for the hardware, this is where our company invests the most on our server, which is Dell PowerEdge 3650. The price tags that you see here reflects that this is not a standard desktop designed to run 24 hours without failing. It has special server grade parts that are more durable and powerful, which is exactly what we need to host our website and central files reliably. So now moving on to the next section, 4.3, software requirements and specifications. First, we have our operating system, which we will be using Windows Server 2022 Essentials, which will be paid on the one-time use. Next, we have our Office suite and collaborations. We will be using Microsoft 365 Business Standard, which we think are the best license software for a business. As you can see here, the price for our Office suite is 13,250 for every year, since it will be needed to renew the license every year. So for the last section, 4.4, installation and other services, this is for our company Sakura Animation Studios to hiring professional IT setup to ensure that all of our new equipment is installed and configured correctly. This is to prevent security risks in the future. So to sum it all up, the total cost of implementation in this project is 39,450 ringgit. We believe this budget represents a solid long-term investment in a reliable and modern IT infrastructure for the company.
Okay, Bismillahirrahmanirrahim. So we have finally arrived at the final part of the presentation, which is conclusion. The network design for Sakura Sendirian Berhad is based on a star topology, where all devices are connected to central points, router 0 for wired segments and access point 0 for wireless connectivity. The setup supports 25 laptops and 5 mobile devices, ensuring centralized management, reliable connections, and scalability for future growth. While the network offers key strengths such as easy troubleshooting and stable performance, it also presents challenges like single points of failure, high initial costs, and potential performance limitations. To address these, we recommend adding redundancy with backup devices, improving security through firewall and VPN configurations, and implementing quality of service to prioritize essential traffic. Network monitoring tools and staff training are also suggested to maximize system efficiency. Overall, the implemented design meets the company's current requirements and establishes a solid foundation for future expansion in the animation industry. So that's all from us. Sakura Sindra Berhad for case study number 9. Thank you for your attention. Thank you.